Now we come to the third one, which is called addition. Addition is exactly the reverse of elimination. Okay? I would have loved it because in mathematics you say addition and subtraction. Here they say elimination, you're removing. Addition is to put back. Ne? Elimination, you start with one, you separate them. Addition, you start with two, which are separated, right? You join them to become one. You good? Let me make it show you. See, you got two. Can you see that? Look at this one. You at the end you've got what? Double bond and some other compound. Am I right? So you're starting here, you're going that way. You're gonna break a double bond. Sometimes it could have been triple bond also. So you break a triple bond to form a product that will have a double and something. Then you can break again. Okay? Yeah. So addition. So even this one, actually, this one, I could have removed H and H again to make triple bonds, but no need. So with this one again, remember what we were eliminating. It was this one and this one and this one. Can you see that? I said there it was H and gases. Am I right? Here again, you are going to eliminate, let's just call them, like how we did before, H and gases. All right? H and gases and gases. When I say H and gases, I mean it's an H bonded with some gas here, ne? And then when I say and gases, and I mean when you take group 7, even though the H is not there, you just take a gas on its own, like X2, like Cl2, chlorine, Cl2, fluorine, F2, bromine, Br2, but oxygen, O2, the wand, but it's actually there also, ne? Which is called oxidation. Now, to name these guys, I'm just helping you. Remember here. Do you remember here when you remove something? Do you remember how does the name become? It has what? D something something, ne? It starts with a DE, ne? Now this time you remove the word DE. Remember if it was hydrogen, you're removing it. It's called dehydrogenation. But if you put back the hydrogen, don't use the word D. Just say hydrogenation. If it was dehydration, now it becomes what? Hydration. Ah, there you go. If it was dehalogenation, it becomes yes, the D, we just remove the DE only. Can you see how easy it is to remember? Yeah, but you see how teachers, they make it difficult. Like, yo, bafowethu unale reactions engathi. But once you get the trick of this, you're good. All right, so now, also, you say it's the previous one and also the oxygen without bonded with an H, which is actually the group 7 on its own here. Can you see that? Yeah. All right, so now let's just read little information because it helps you. Addition takes place with unsaturated. Okay, in simple terms, when you're doing addition, we are going to break their multiple bonds, double, triple. Am I right? Double, triple bonds are called unsaturated. You remember that? Yeah, it's another fancy word. Can you say how crazy these people are saying? They say it takes place with what? Unsaturated. Like, what is unsaturated? If I say I, double bond and triple bond, you're like, oh, I know those things. But if I say the bonds were unsaturated, you're like, what? What does that mean? I say the bonds were double like triple. You're like, oh, yes, that one is easy for me. All right, you see, they try to trick us with the grammar. We will grammatize them. All right. It takes place with double or triple bonds compound, which are usually more reactive than saturated compound. So the double, triple, multiple bonds, they react more reactive. And then they say takes place with a double bond and triple bond. That's what we said. Two atoms are added across the electron-rich bond. You don't even need to worry what's that. I'll tell you what's happening. Here we go. Let's take this one. You have C double bond and also C here, and then 1, 2. It's done. Am I right? 1, 2. Remember, you know how to count that carbon must always be surrounded with 4. For what? Yeah, or 4 bonds. All right. So now it's alone. It's like that. We know there is H's now. So when I break that one bond, you see when I break that bond, one bond. Remember when you make a double bond, you took 2 bonds to make them one. Am I right? So the one that I'm breaking, it's actually 2 pieces joined together. Am I right? So which means one piece goes that side, one piece goes over to the other side. Then you see that Cl, there are 2 Cl's, am I right? One will go that side and the other one will go to the other bond. That's it. If you had X2, you'll put the 1X here and 1X over there. But we'll see later when we're going to do what we call Markovnich's rule. You know Markovnich's rule? No. They didn't tell about Markovnich's rule? No. Okay, Markovnich's rule, I'm going to show you. It's called the rich gets richer, the poor gets poorer. Okay, so let's just read here what just occurred. We say addition of halogens. You see? Which was this one? Can you see? The first one. Then we're going to go addition of hydrogen, addition of water, addition of halogens. Am I right? Yeah. And then you can name the thing later. We're not worried about naming. Everything you know here, I don't have to read it. When you read it, it sounds like, what are they saying? But it's what you know. It says, normally occurs dissolve in a solvent such as chlorine tetrachloride. They say alkenes, which is double bond, form dihaloalkenes. It's exactly what you're saying. How will you name this one? How many chlorine are here? 2, ne? You wouldn't say dichloro, difluoro, dibromo. But instead of saying chloroplumber, you know those guys are called halogens. Ne? It's a dihalogen. Am I right? Yeah, dichloro, that's what it is. You know, now it makes sense. Now we've got alkenes, meaning in a triple bonds. Am I right? Yeah, they'll also form that one. You don't need to know. It will happen by itself. Now we are, okay, they didn't tell us. Okay, this reaction is called halogenation. Remember the other one, it was dehalogenation. Yeah, it's halogenation. Here they didn't add it to the notes because we are adding halogens. So it's halogenations. Next one, they say addition of what? Hydrogen. So it should be called what? Hydrogenation. There we go. So now, here's this H. You see, right now we're adding mafana-fanai, twins. What do I mean by twins? It's because, you see you've got chlorine here and chlorine, ne? Now, let me do positions here for you so that I can explain what do I mean. This one I'll call it position A. Here I'll call this one position A. This one I'll call it position B. Now, you see, there's 2 chlorines, right? Let's delete them and draw them in color. I say chlorine, the white one. I say chlorine, the blue one. We good, ne? Does it matter where the white chlorine goes, by A or B?
No.
It doesn't, ne? No. Because they are really the same, ne? Yeah, you cannot even tell that it's because I put them color. Because if I put the white here or the blue there, you wouldn't know which one was it. Yeah. But once there is something like this, let's say it was not chlorine and chlorine, it was not like what I'm saying, twins. If I write H there, then there'll be hydrogen and chlorine. You can tell whether chlorine went to A or B, ne? That's where we're going to use that rule, Markovnikov's rule, because it's going to matter. It's going to matter where you place the H. I'm going to tell you that later. All right. All right, so now, same thing here, it's hydrogen and hydrogen. Am I right? So it does not matter where you put it, so I remove that one, and then I'll have a bond. I'll have an extra bond here. I can put another one up there. Then I put H there, and I put H over there. You cannot tell the difference between the H's. They look exactly the same. Hydrogenation. All right, and then the other one, that's when we are going to, they say we are going to add water. Instead of calling it dehydration, it now becomes what? Hydration. Yeah, or watergenation. All right, so remember what's happening here. We need H and the OH. Can you see that? All right.
Hello.
So can you see, you can tell the difference between the H and the OH, where H will be and where OH will be, because they don't look the same, those guys. Am I right? All right, so if I break the bond and make it one here, I'll have a bond here. And then I'm going to have a purple bond there. Okay. This time I'm not going to say anything yet. So you can put your H here. You can put your OH over here. We good?
Yes.
That's it. Now, anything that has an H and something else, it matters where you put the H. Now, let's see if they've got that one. Yeah, let's come here. This one, it's now hydrogen and halides or halogens. Can you see that? Yeah, so this must be called halogenation reaction. We good, ne? Yeah. Now, can you see now? You had dehydrogenation, one. You had dehydration. Am I right? And then you had dehydrogenation, like S3. Am I right, ne? And then you also have the opposite of them. Now it looks like there are 6 now. Meanwhile, it was the same thing. I just removed D. Am I right? Yeah. It's like count, discount. You see? It's same word. And then teachers will say, you see, we've got now 12 reactions. You're like, yo, but for it, the reactions are sharp. There's too much. There isn't. All right. Now, watch now. Maybe this is their own example. Let me give you my own example. All right, my own example. Let's have, see here. Let's have, there is what we call the rich gets richer. Am I right? Yeah. All right. So let's just take this one here. This one here. Which is actually what I'm after. I'm actually after, let's say you had this one here. And then, all right, let's just leave what I'm saying, because now I might get you mixed up. All right, fine. Yeah, here's what I wanted to say here. The other one I said, not fluorine. Can you see? Fluorine, I think, is the first one right at the top, so we don't use it. So now when you break this bond, when you break it here, there it is. Then you have that, you have that. Now I want you to consider now. Let's call this one carbon 1. Let's call this carbon 2. Now it matters where you put the H, okay? Yeah, I'm gonna just introduce it here. Here's the question. Between carbon number 1 and carbon number 2. All right, let me put it this way. Carbon number 1, it's surrounded by how many hydrogen at this moment?
Hello. Hello.
2. Carbon number 2, it's surrounded by how many carbons at this moment? So carbon 1 and carbon 2, they've got the same amount of hydrogen bonded to. Am I right? So it does not matter in this case where to put hydrogen. You can put hydrogen here. You can put X here, because there was no carbon which had more hydrogen around it, rich in hydrogens. We good, ne? All right. Now here it's a same scenario here. Let's start it here, because here it's the same thing here. This carbon has 1 hydrogen around it, correct? This one has how many? 1. You break 1 bond, they make 2, and then this is what happened. This is what they had 2 bonds here. They've got 1 H there, 1 H there. So it does not matter where the H goes. But now, if the reaction started from here, from the yellow box, let's say the reaction started from there, you are about to break that double bond. That's where Markovnikov's rule comes in now. Watch now. Because we've been tracing it, we've been finding both the carbons had the equal number of hydrogens around it. Am I right? Now, this one in a yellow box, let's look at the carbon. Let's call them numbers again. Let's call this one carbon 1, and then carbon number 2. All right, so what happened is, on carbon 1 and carbon 2, tell me which carbon has more hydrogens around it. Huh? Yeah, I said which carbon has hydrogens around it? More, ne? It's number 1, ne? So that means the H must be given to carbon number 1, the one that has more hydrogen in this case. That's the Markovnikov's rule. They won't even ask you to state it. They won't ask you that. That's what they say, the richer becomes richer. The carbon which is rich in hydrogen, give it hydrogens more. Can you see that? That's they call it Markovnikov's rule. So we done.